These are the video solutions to Task 1B 2016, working mathematically for measurement, perimeter and area. Calculate the area of a rectangular netball court with length 30 metres and width 15 metres. Okay, you can sketch it if you want. So we've got 30 metres, 15 metres. The area of a rectangle we know is length times breadth. So it's 30 times 15, which is 450. Make sure you put your units, metres squared. Question 1B. Draw two different rectangles with an area of 12 centimetres squared on the grid below. 12 centimetres squared, just think of any two numbers that multiply to give 12. We know that 1, 2, 3, 4, 5, 6 times 2 is 12. There's one rectangle, 6 times 2. Another rectangle might be 3 times 4. They multiply to give 12, so 4 times 3. But I can think of another one, and it's 12 times what gives 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 1 is a third one. So you can have any of those three. 6 times 2, 4 times 3, or 12 times 1. You don't have to have them all. Joanna states that rectangles with the same area have the same perimeter. Use your rectangles to justify your answer. So I'd be drawing one of them, this 2 times 6 one, and I would say the area of this is 6 times 2, which is 12 centimetres squared, but the perimeter of this one is 2 plus 6 plus 2 plus 6, which is 16 centimetres. Then you might want to draw another one here, your 4 times 3 rectangle, and you can say, well, the area of this one is 4 times 3, which is 12 centimetres squared, but the perimeter is 4 plus 3 plus 4 plus 3, which is 14 centimetres. You could also do the 12 times 1 as well if you wanted, but we don't have to. The 12 times 1 rectangle will have a perimeter of 26. Okay, so they're all different. So therefore, I disagree as the perimeters are different. The areas are the same, but the perimeters are different. Can you see that? That's how you would justify that. Question 2, find the length of the rectangle below if it's got a perimeter of 30. So girls, if this side's 6 centimetres, so's the other side. Why don't we see what, we know that the perimeter is the addition of 4 sides. So we can see what we've already got. 6 plus 6 is 12 centimetres. Then these two sides therefore have to add up to what? 30. Take away 12 is 18 centimetres. So the two remaining sides add up to 18. So therefore the length will be what? 18 divided by 2, which is 9 centimetres. Girls, the way you do it, if the whole perimeter is 30, that means the addition of the 4 sides is 30. Let's see how much we've already got. 6 plus 6 is 12. So far, I've got 12 centimetres. The whole perimeter is 30. 30 take away 12 is 18. So therefore, these two sides with dots have to add up to 18. Now, they're both the same length. So we do 18 divided by 2 is 9. Or what plus what gives 18? 9 plus 9 gives 18. Let's just check it. So let me check. 9 plus 9 plus 6 plus 6. Yes, that is 30. Because that's 18 and 12 gives me 30. So your answer is 9 centimetres. The next question. A square, so the square in the middle has an area of 16 centimetres squared. So I'm going to draw that square. Its area is 16 centimetres squared. Girls, with a square, to do the area, something times something has to give me 16. And it has to be the same number. So area 16 is really 4 times 4. So the side length of my square equals 4 centimetres. So therefore, all these dashes are 4, which means all the outside dashes, because we've got equilateral triangles here, all these dashes are all 4. So all these are 4. Okay? Now, so what is the length of one side of the square? Sorry, I should put that all in there. So all this working out should go here. The area of the square is, sorry, side length of the square is 4 centimeters. Now the perimeter of the new shape, I have to add all these up. How many 4s am I adding up? 4 times 8 is 32 centimeters. So I'm just going to write this here again. Area of square is 16 centimeters, which is 4 times 4. Therefore, side length is 4. 2 equal-sized parallelograms overlap, as shown. There are 2 ways to do this question. Girls, you can actually just, do you see this shape up here that I'm putting my pen on? So I've got 2 parallelograms and they overlap. I'm outlining the parallelograms now with my pen. Now, and basically this bit is white, so it's not shaded. I have to work out the area of the shaded bits. So what I would do if I were you, I'd call this maybe shape number 1 and this shape number 2. Now shape number 1 and shape number 2 are the same size. So I think you should just work out shape number 1 first, area 1. Now there are 2 ways of doing this. If I want to work out area 1, how do I make that shape? I start with the big parallelogram. Alright, to work out the first area, this first area 1, it really is the big parallelogram which has height 16, so perpendicular height 16 and base 8. So to do the area of a parallelogram, girls, it's base times perpendicular height. So the area of this first one, I'll just get rid of that. The area of this big one is 16 times 8, which is, what is it, girls? 128 centimeters squared. Now watch what I'm going to do. I've got that parallelogram. What if I cut, just watch over here. Big parallelogram, watch. Cut this out. Cut this out. Aren't you left with that shape? Do you see that? If I take the big parallelogram and cut out the small one, remove this, I'm left with shape number 1. So I'm going to do this small parallelogram. So the small parallelogram down here is 8 high. If this is 4, then this is also 4. And 4, so it's got height 8 and base length 4. So the area of this little one is 8 times 4, base times perpendicular height, which is 32 centimeters squared. So therefore, this shape, this area, the one that looks like that, so therefore the area of this shape will be 128 minus 32. Do we get that, girls? Yeah. And 128 minus 32 is 96 centimeters squared. So that's that shape. Girls, the whole thing is made up of 2 of those. Shape 1 and shape 2 have the same area. So therefore, your total area is shape 1 plus 2, which is 96 plus 96, which is 192 centimeters squared. That's one way to do it. There is another way to do it. There's another way to do it, but it's a little bit tricky. Way to do that problem. One way is to work out the area of this shape and then say that you've got 2 of them and add them together. There is another way, and I'm sure it's the way that most people have tried to do the problem. So, the other way is to do, here's my first parallelogram. You need to watch, look at the video. And here's the second parallelogram, right? Now, when I put them on top of each other, and this bit gets sort of cut out, I have to take away this bit here, but I've also got to take it away from that. So I can do, so can you see how the new shape doesn't have all that in there? So what I've got to do is cut those both out, okay? So the way to do it in a second method is to go like this. So I'm going to cut, and I'm going to cut. So girls, so most people went like this. They said the area of the parallelogram, the large one, is 16 times 8, which is 128. And then they did 128 times 2 is 256. This is how a lot of people would like to do it. They'd like to do the area of the large parallelogram and then double it, because you know you've got two parallelograms. But what a lot of people didn't do, the mistake that a lot of people made was, so I've got my two parallelograms, okay, I've done them. I've worked out the area of these two. But what a lot of people now did is work out the area of the small one, which is 8 times 4, which is 32, but they only took away the 32 once. What you've got to do, here's my parallelogram, watch, there's my other parallelogram. If I take away a 32, I've still got this shape. I need to take away the other 32. So I'm going to cut that out. So you see how I had to cut away, and now I've got the shape. So I had to cut out 2 of these to get that shape, not one of them. Do you see that? So therefore, you do 32 times 2, because I've got to take it out twice. So what you do, this is our second method. 2 big ones, 2 small ones. The area of the small ones. The area of the big ones. 2 of them. And we do 256 minus 64, and you'll get 192. Same answer as before. Okay? Now, a lot of people were able to do the first bit, double it, but they only took away 1 of the parallelograms, not 2. The last question. Alexia's bathroom floor is in the shape of the shaded figure or diagram below. So basically, it's a rectangle, but this triangle is cut out. So find the area of the bathroom floor. You've got to do the rectangle minus that triangle to get the shape, the area. So girls, what's the length of the, sorry, it's not a rectangle, it's a square. What's the length of that? 4 times 4. Now this is where a lot of people would make a mistake. They wrote 3 times 3. So the area of this is 4 times 4, and this triangle has got base and height 1. So how do we do the area of the square? It's 4 times 4. But the area of a triangle is a half times base times height, which is a half times 1 times 1. Okay, so the area of the square is 16 minus the area of the triangle is 1 times 1, and then you've got to halve it. Now, 1 times 1 is 1, and if you halve that, you get a half. 16 minus a half, which is 15.5. Girls, but this is meters squared. That's meters squared. How do we convert from meters squared to centimeters squared? Girls, how do you convert from meters to centimeters? 1 meter is 100 centimeters. But if you want to do meters squared, you've got to do it twice, times 100 twice, or double the zeros. So to go to meters squared, you go 15.5 times 100 times 100, which is 155,000. I'm going to move it up here, which is 105,000 centimeters squared. 155,000 centimeters squared. See, when you see a question like this and they say find the area of the bathroom floor in centimeters squared, what you should really do to make it easier, I'm going to do it again, is to change all these to centimeters to start with, and it would make it a lot easier. So instead of doing 4 meters times 4 meters, you can do 400 centimeters times 400 centimeters, and then your units will come out as centimeters squared. And instead of doing a half times 1 times 1, you can do a half times 100 times 100. And that will all be centimeters and centimeters squared. So sometimes it's easier to convert the units first. All right, and then you would have ended up with that. But I've done it this way now anyway. All right, now, this last bit. Alexia wants to cover the floor of her bathroom with square tiles. One pack contains 40 square tiles measuring 10 centimetres by 10 centimetres each. So girls, I've basically got this shape. Of course, and we're going to put lots of little square tiles in there. And when we get up here, we're obviously going to have to cut them. Okay, so lots of little tiles are going to fit in here. Now, we know that the area of the floor is 155,000 centimetres squared. And we have to fit all these tiles. Girls, each pack has got 40 square tiles. Each square tile is 10 centimetres by 10 centimetres. Let's just work out the area of one little tile. What's the area of one square tile equal to? It's 10 centimetres times 10 centimetres. So one of those little tiles is 10 times 10, which is 100 centimetres squared. Good. Now, Alexia wants to cover the floor of her bathroom with square tiles. One pack contains 40 square tiles, each measuring 10 times 10 centimetres. Don't worry about the pack yet. Let's just work out how many tiles we need. Then we'll work out how many packs at the end. When tiling, one extra tile for every 10 tiles is needed because tiles need to be cut and some tiles will break. How many packs does she need? Don't worry about any of this yet. I want you to ignore the wastage. Can you tell me if the floor is 155,000 centimetres squared and each tile is 100 centimetres squared, can you just tell me how many tiles you'd need, ignoring the breaking? How many tiles? Just ignore that some are going to break. How many tiles do you need? Tiles needed. How do you do it? If each tile is 100 centimetres squared and the whole area is 155,000 centimetres squared, what do we do? Divided by. You see how many hundreds fit into the 155,000. So you go 155,000 divided by 100, which is 1,550. Now, girls, that's needed if nothing breaks. That's how many tiles you need. But we need extra tiles in case they break. Now, it says one extra tile for every 10. So if you really need 1,550 tiles, how many of those could break? 1 in extra 10. What are you going to divide this number by? Yeah, but need extra tiles. 1,550 divided by 10. You need an extra 155 tiles. Does that make sense? So that's exactly how many tiles you'd use if none of them broke. But they're saying you need to buy an extra 1 for every 10 tiles that you need. So if I divide this by 10, I get 155 tiles. So I need an extra 155 tiles. Therefore, the total tiles needed is 1,550 plus 155, which is 1,000, anyone? 705 tiles. So we need, so I'm adding 1,550 with the 155. I need 1,705 tiles. Now, how many tiles in a box? How many tiles in a box? Therefore, the number of boxes that you need will be 1,705. What do I do now? Divide by 40. And can I have an answer, someone? Tiles, therefore, how many tiles?
42.
How many boxes? No. Girls, if you buy 42, you don't have enough.
43.
You need 43 boxes. You need more than 42, don't you? So therefore, you need to buy 43 boxes. Just back here, the tiles needed without any breakage or extras would be exactly that. So you need extra 1 in 10. You need those extras. You need to add them together and divide by 40 tiles per box and then round up.